We're on the last section of, or last part of section 2.2, stretches and shrinks. In your student journal, you'll actually notice that the horizontal stretch and shrink comes first, but I think it's a little bit confusing to explain. And so I'm actually going to start off with vertical stretch. I think it's a lot more intuitive. Vertical stretch and shrink. So the graph of y equals a times f of x is a vertical stretch or shrink by a factor of a of the graph of y equals f of x, where a is greater than 0 and a is not 1. Because if you multiply anything by 1, you didn't change it. Multiplying the outputs by a stretches the graph vertically when a is greater than 1 away from the x-axis. So they say away from the x-axis so that you like kind of realize that, oh, it's getting taller, it's getting stretched out. When a is greater than 1, and shrinks the graph vertically toward the x-axis, or it gets shorter is how I think about it, when 0 is less than a is less than 1. So when a is between 0 and 1. It says multiplying the outputs by a stretches the graph. So here I made it so I have a is equal to 2, and then a is equal to half. And here's what that looks like, 2 times f of x, and then 1 half times f of x. It says multiplying the outputs, and that's all that's happening. We're just multiplying the outputs. So when we multiply the outputs, we get 10, we get 6, we get 2, we get 6, and we get 10. It says when a is greater than 1, it stretches the graph. It's a vertical stretch, and it goes away from the x-axis. So what that looks like is it's going to stretch away from, so that means whatever is here, what's away from, it has to get further up or taller. And oh, look, it does. So this is our original graph, f of x. Oh, sorry, I didn't even say it in the last part. Our original, this is the function I just made up for an example. So f of x equals absolute value of 2x plus 1. So I plug in these x values, I get these values for f of x, the output values, and I made a little t-chart. And these are t-charts for a stretch and a shrink. So we have our stretch right here. This is what that looks like. So the y-coordinate went from 1 to 2, from -1, 3 to -1, 6, right? And so on and so forth for all points ever. Next, let's look at a vertical shrink. So a is 1 half, so we're going to say 1 half times the output. So 1 half times 5 is 2.5. And then 3 times 5 is 1.5. And then 1 times 0.5 is 0.5. And then, yeah. So we are shrinking. We are getting closer to the x-axis, or we are getting shorter. So here is what that looks like. Oh, look, it got shorter. Went lower, 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 lower. It got towards the x-axis, right? So instead of 1, we're at 0.5. And then instead of 5, we're at 2.5. So that's it for vertical stretch and shrink. Pretty intuitive. You just multiply the outputs by a. If a is greater than 1, that's a stretch. If it's between 0 and 1, it's a shrink. Okay, this one tends to be more confusing for students. And it's also more confusing for me to explain, I'll be honest. The graph of y equals f of a times x. So before it was a times the output, but this is a times the input. Is a horizontal stretch or shrink by a factor of 1 over a of the graph of y equals f of x, where a is greater than 0 and a is not 1, because if you multiply by 1, you haven't changed anything. Multiplying the inputs by a before evaluating the function stretches the graph horizontally away from the x-axis when a is between 0 and 1, and shrinks the graph horizontally toward the y-axis. So if it's shrinks the graph horizontally toward the y-axis, that means we're getting narrower, right? We're getting closer to the y-axis. Whereas stretching it horizontally or pulling it sideways means getting wider. When a is greater than 1, that's a shrink. When a is between 0 and 1, that's a stretch. So here I've picked a number 2. So f of 2x is the same, but we are multiplying the inputs by a. So what would I have to multiply by 2 to get -2? So sit here, think about it. It's -1. And what would I multiply to get, what would I multiply by 2 to get negative 1? The answer is negative 0.5. And what would I multiply by 2 to get 0? The answer is 0. And then 0.5, and then 1. So we're multiplying the inputs by a to get the same, to get it back there, basically, to get it back to our starting function. So this is a factor of 2. A is 2, but the factor is 1 over a. Right? So I'm going slowly because this can be confusing. So since a is greater than 1, that's a shrink. So we're going to expect it to get closer to the y-axis. So let's see. That's this one. So if it gets closer, that means it's going to be narrower, right? Oh, and look at that. It's narrower. And whereas before we said, negative 2 would be at 5. Well, we cut this in half. We got negative 1, which is what I was trying to illustrate with the t-chart. So what kind of factor is this? Well, a is greater than 1, so 2 is greater than 1. So this is a shrink factor. It got narrower, so that's a shrink, closer to the y-axis. And the factor is 1 over a, or 1 over 2. So that's that. A horizontal shrink, a factor of half. A is 2, and it gets narrower. Next, we're going to look, we just looked at a horizontal shrink, so, what do you guys think this is, right? So, to get the same outputs, then what do we do to this? Well, here, I had to say, okay, what number multiplied by 2 gets negative 2? We're going to do the same thing here. What number multiplied by half gets negative 2? So what number multiplied by 0.5 makes negative 2? And the answer is negative 4. What number multiplied by 1/2 gets negative 1? Negative 2. What number multiplied by half gets 0? 0. And then 2 and 4. So looking at this again, we'll look at the graph in a second. Oh, let's just look at the graph now. So what movement are we expecting? This is a stretch. That means it should be going away from the y-axis. Away from means getting wider. Oh, wow, look at that. So let's take a look at some of our points just to verify. So we said negative 4, 5. So it went from negative 2, 5 to negative 4, 5. Right? And that's just one example. Obviously, you can look at the other ones if you want. And so this is going to be a stretch factor of 1 over a. But a is 1/2. So 1 divided by 1/2, or 0.5. 1 divided by 0.5 is actually just 2. So there you have it. Again, this one's a little bit more confusing, so you'll have to pay a little more careful attention in terms of horizontal stretch and shrink, in terms of like the language around it. A shrink factor of 1/2 means a is 2. 2 means we multiply these inputs by that number by a to get what I don't want to, you could call it the parent function, I guess, in this case, or the original function. But yeah, let me know if you have any questions.